As an engineering leader, I've seen deadlines come and go. Let's face it, delivery date forecasting can be one of the most challenging parts of our job. Commit to a long, drawn-out timeline and risk having your team look like it's underperforming. Commit to an overly ambitious timeline and watch your team burn out. More often than not, what I've seen historically is that the engineering leader will commit to that overly ambitious timeline and their team will end up working at an unsustainable pace to meet that unrealistic deadline. We can break this cycle. In this video, I'll walk you through my forecasting system. It's a 4-step process that helps external stakeholders understand the scope and complexity of the work that we're committing to, gets buy-in from the engineering team as part of the process, and yields documents and diagrams that might help the engineering team once the project has kicked off. So let's dive in. Here's my forecasting system. First step is component diagramming and architectural documents. We break down the work into components within the architecture that are affected by the changes and write up any architectural documentation that records key technical decisions that were made during the process. Then we will go through a t-shirt sizing exercise. Small, medium, large, extra large. I'll go into a little more detail into what that entails in a second. Then we have refinement and story pointing. We go a little deeper into what's needed for each component and break it down and story points to it to more granularly attempt to estimate the amount of time spent on each part of the project. And lastly, Gantt charting. I'll be referring to it a lot as road mapping. I think that road mapping a lot of times can be attributed to something that a product partner would do, which is more high-level mission goals. And what I'm attempting to do here with this Gantt charting is laying out in a visual representation what the timelines are going to look like and what work is parallelizable, what resources we'll be using for each track, and I'll show you how to do that as part of this. So let's talk a little bit more about story pointing. In traditional agile methodology, you assign story points to tasks that are called user stories with a Fibonacci sequence. And that is a sequence of numbers where each subsequent number is the sum of the two previous numbers before it. I find that anything outside of an 8 shouldn't be brought into a single sprint. It should be broken up into more executable pieces of work. So we've got 8, which equates to a single sprint. And then you've got 5, 3, 2, 1. 1 being the simplest level of effort. Usually it means changing a single line of code. And everything in between is a relative weight in comparison to those. In traditional agile training, you're kind of coached to stay away from estimating user stories as amount of time. And I find that engineering leaders, when they shift from individual contributor to leadership, they have to shift that mindset a little bit because suddenly they're forced to communicate in terms of timelines, whereas an individual contributor, if they are true agile, they're only going to be talking about things as level of complexity. So that's why story pointing here with this method is a bit vague. And let's talk about t-shirt sizing. We've got extra large, which usually means around 2/4, large around 1/4, medium would be around 3 to 6 sprints, and small around 1 to 2 sprints. Here are some practical examples of how I go through each step of this process. Let's imagine a project where I am adding a messaging system Think about an application like YouTube where multiple users can update my channel settings. So I want to be notified via SMS every time a change is made to my channel settings. This and every case that I'll give you here are strictly hypothetical. These are not real life scenarios. But let's say there was a requirement to implement this messaging system. So here we have a YouTube-like application, and you have channel settings microservice. You have an endpoint that updates the user settings that's already existing. And we have done some research, and we found that Twilio SendGrid is a third-party service which we can integrate with, which offers SMS messaging services. So we've decided to integrate with that third-party service. So here in the channel settings microservice, we will be triggering a notification. So we have to add some logic there. So this is a pretty simple, straightforward project. One is to add notification logic to the user settings update. And then we integrate with the Twilio SendGrid service, do some end-to-end testing there, and progress through the environments until we get to production. We implement some error handling and retry logic. And as part of this exercise, we have also found that we want to manage the API keys. The notification logic we have found to be a small. The integration with Twilio SendGrid, a medium. Error handling and retry logic also looks like a small. And API key management, also a small. And that's new. So let's add that to our diagram here. Here we have our CI/CD pipeline, and we're going to add scripts to add as environment variables these keys to each different environment. So here we looked at the Twilio SendGrid documentation. We have confirmed that the notification logic is in fact small. We gave it 3 points. And to integrate with Twilio SendGrid, we've determined it's a medium. We gave it 8 story points. So we're saying that it's gonna take a full sprint to fully integrate. And this is because, like I said before, you have to promote through environments, do end-to-end testing all the way through production, and you have to have high confidence that it's working well in production, because once this goes live, there will be real messages going to people's real phones. So we have to be really careful. There's some risk involved here, so we have to be really meticulous about how we're integrating. So the phone number is a necessary data point to complete this transaction. So we need to get the user phone number from the user settings data, and you use the Twilio account SID as well as the Twilio auth token here. And I think we have to do some digging around what that means, because when I hear auth token, that sounds to me like it's a temporary token that gets refreshed. I have not looked too deeply into this, so there's some complexity that could present itself here, but the account SID will be that environment variable that we talked about. And then we have number 3 here, implement error handling and retry logic. That's a bigger small, so we story pointed it as 5 story points. We have to make sure that we're only retrying if the error is transient in nature. So maybe we hit the rate limit for this request, so that's a type of error. Or maybe the service was temporarily unavailable. We're probably not going to be retrying if the error is in 400s, like couldn't find the service type of situation. And we also determined that API key management is small. We will configure the Twilio account ID as environment variables and have the CI/CD pipeline set those variables for each environment. So let's start road mapping this. I have 2 engineers who are going to be working on this. I've got Dinesh and Guilfoyle. If you know, you know. Let's look at this mock roadmap, very rudimentary. We have Dinesh going ahead and setting up the API management system. Everything else that comes before that is very subsequent in nature, so I won't be able to parallelize 1, 2, and 3, but we'll have Guilfoyle add the notification logic first, then integrate with Twilio SendGrid, and then implement the error handling and retry logic. Pretty straightforward. So I want to make sure that we're committing to a fully hardened, well-tested product, because like I said, there's some risk involved here as we're implementing this. So I want to make sure that we give ourselves an extra sprint to test and harden this feature. So that brings us to a 3-sprint delivery date. The forecasted date for this project is around 6 weeks from start date. There is a lot of room for scope expansion here, to put it nicely. There are some gaps in the requirements that were given to us. And as an engineering leader with the experience that I've had working on projects like this, I can see the potential gaps and where products might come back to my team with requests. Once these messages make it to a real phone that people can look at, they're going to want to customize these text messages. And customized messages should be part of the requirement. So we're going to make sure that once the engineers start working on these things, they have a clear message that we're going to be sending to the user. However, if they want dynamic information to be included in the message, that might be a scope expansion if we don't have the dynamic data readily available to us with the microservices that we're accessing. They might want to expand their messaging to emails. So dynamic templating, more customization in email messaging. That's also outside of the scope of this project. Allowing users to opt out of notifications. As a requirement for this project, everybody is opted in by default, but I believe that it's a law that you have to give users a option to opt out of messaging, even if it's not for messages that are marketing in nature. Even if they are security notifications, you should still be able to opt out. And who knows, maybe Twilio SendGrid has functionality to do that out of the box, but still they have to talk to us and probably have us set that into our user settings. Otherwise, we're making extraneous calls. If they're blocking these messages on their end, we're going to be making unnecessary calls, and that's not graceful. So addressing that may or may not be within the scope of this project. If you want to get really fancy and you are planning on implementing notification and messaging outside of the channel settings microservice, you might consider implementing a message bus, which decouples that notification logic from the channel settings microservice and makes it its own thing. So each microservice can then call that message bus service and have potentially faster messaging, synchronously sending messages to the third-party service a little more quickly, potentially. I feel like that's more of a engineering desire than product, but who knows, it's something that might come up and we might consider doing in the future. We could also determine that we want a more robust key management system. As a security recommendation, we might want to schedule key rotation. This just makes it a little harder for nefarious entities to try to send messaging on our behalf. If we're rotating our API keys, it just makes it less likely that they'll figure out how to spoof a call from us. So this means creating a web function, a Lambda, that schedules a refresh. Twilio SendGrid has APIs that allow you to generate new keys and set them by environment, so a system that does that for you. That would also be a great enhancement to this feature. That is also something to talk to product about as future enhancements. Let's move on to the next example. So think about a website that displays information about stocks. So you already have an interface that lists stocks. You can search stocks by ID or by name, and it pulls up information about it. Most importantly, the current price of that stock, and then maybe historical data to chart the trend for that stock. And imagine that that website now wants to give a user the ability to watch each stock and view each of those stocks they're watching within their own dashboard interface. So let's look at the diagram here. We have the existing web application, which allows you to search and view stocks. We have a new ask to watch stocks and create a new My Stocks dashboard. The web application currently makes calls to a third-party stock API, which gives you the information about the stock. We have a user profile microservice. Say that this website already manages users because they pay to view more premium content. So you have basic user information, you have ways to create a new user and edit that information. We will be adding watched stocks to that user information. And because we have a user database, we'll be adding watch stocks table to each of those users. So for the t-shirt sizing, we've identified a few high-level tasks here. Watch stock action, the watch stocks dashboard, and the watch stock action is a large, and new watched stocks dashboard is an extra large, just based on high-level conversations with engineering teams. So we've determined that the watch stock action is an epic with a few stories. The first is to add a watch stocks table to the database and update the schema for the user data table and run a migration script to have previous data include that watch stocks table. We will be adding a watch stocks endpoint with post, get, delete methods, and we will add a clickable watch component in the UI, which calls that new watch stocks endpoint. And we will be adding monitoring and logging for the user profile microservice. So that's one epic. The other epic is the new watch stocks dashboard. First story is to create that new dashboard interface, which gets a list of watch stocks and then fetches each from the third party and renders a list. The engineer will be building that UI and then making a call to that user's watch stock IDs, and then it's going to take that list and ask the third party API for information on each of those IDs. And then they will establish a WebSocket connection to update the UI with new prices. I'm not sure I mentioned this before, but part of the requirements is to update live the price of the stocks. Say every 2 seconds, you'll get a live update on that stock price. It's a completely hypothetical number. The WebSocket connection will allow the UI to subscribe to updates to that information, and every time there's an update, the UI will re-render to show that new stock price. So actually here, after we laid out this information, we've determined that these items are probably a little smaller than we originally t-shirt sized. The watch stock action epic we can call medium, and the dashboard will call a large. So let's get to road mapping. I've got Jared and Erlich helping me this time. Again, if you know, you know. Let's look at this roadmap. I'm gonna have Ehrlich add the watch stocks table to the database, add the endpoint to the microservice, and I will have Jared do the UI work for us. He's gonna start by adding the watch component to each stock component, and then I'll also have Ehrlich add monitoring and logging for these actions. And for the dashboard epic, I will have Jared create that new interface, and I will have him also establish the WebSocket connection through the UI. You'll see here that for that dashboard interface, number 1, I extended the forecast a little bit. I did say that a 8-point story is a full sprint, but historically what I've seen, especially with new UI, there's a good bit of back and forth with UX, and there usually are findings that people haven't previously thought about before the UI is built. There are things like loading, success, error states, active states, hover states. There are a lot of nuances to user interaction that are exposed once that UI is laid out. So just from practical experience from the past, I know that they're going to need a little more time to iron out these potential wrinkles. And then I also want to include a full sprint for testing and hardening. And this is because there's a complete new route. There is a new WebSocket functionality that we've never used before. There are a lot of new things that we need to harden. There's unit testing that will be implemented each step of the way, but still, once everything is complete, making sure that those integrations are smooth and working properly. I want to make sure I'm giving us a full sprint to figure all that out. So my forecasted date is around 8 weeks from start date. And, you know, if we're rounding up, this chart saying 8.5, I would say more like 9 weeks, just to be safe. For my third example, let's close our eyes and imagine a little bit. Bear with me. Say we have an existing application, lists available cars to rent within a given area. These are rental cars that are available in traditional rental agencies. Now, let's posit that this company wants to spin up a sister product which allows independent renters to list their own personal cars, and then there's an interface that lists those listings. Let's call this sister company Air SUV. Let's look at the diagram here. Here we have the new application, Air SUV. Let's say we already have an existing listings portal. Let's say we've already started getting beta users to use an interface to list their cars. So we've already got a service with car information. We've got a database that's storing that car information. And there's a new request to have an interface that renders each of those listings as search results. Here you have the independent rentals microservice, which is existing, like I said, car listings API, and there's a new ask to add location filtering for that search results page, which will ultimately lead to booking those cars. And we have that existing database. Now here on the other side, we have the existing older application. It's a monolithic application and it lists agency rental listings. Now what we want to build is an aggregation service which fetches the new independent renter listings and the legacy agency listings. There's some logic involved to populate enough listings. So say for my particular area, there hasn't been a lot of buy-in from independent car owners yet. So when I search, instead of seeing a blank page or a page with not a lot of results, Air SUV wants to populate that list with some agency listings, which will then drive traffic to the other website. If I have more than 10 results in my area, we don't need to populate that list with any more agency results. So there's a ratio logic there to populate accordingly. And then we merge the results and we serve them as a JSON file where when the UI consumes it, it all looks like a single data type. Let's do some t-shirt sizing here. We have that listing aggregation service, and we have the filtering for the independent listing microservice, and we have the search results UI. We think the aggregation service will be large. The filtering logic should be fairly small because we already have everything that it depends on, and the UI will be also large. So in the refinement process, we looked into the dependencies of the listing aggregation service. We spoke with the engineers who own the monolithic application, and we found that the monolith does not have an API. Great. So we took a step back here, and before we can t-shirt size and refine any further, we're going to talk about what it's going to take to create an API for the monolith listings. Look here at adding the API to the monolith. As our engineers collaborated, we found that there's going to be quite a bit of work to bring that monolith up to a state where an API can be implemented. This team's going to have to work together to agree on standards and architectural decisions. The teams will have to work together to define clear API requirements. While they're doing that, there's parallel work that can be done. So while the aggregation service can only fully integrate with that monolith API once it's been fully released, the engineers can do a lot with mock data, and they can also already make calls to that independent user listings and do a lot of work there before they aggregate with the actual monolith service, including the ratio logic that can all be done with mock data. And for the UI can start integrating with that aggregation service as soon as it starts serving up user listings. It doesn't have to have the agency listings yet in order for the UI to start integrating, because the hope is that once those agency listings come through, they're gonna have the same schema, so the UI can treat it mostly the same. Of course, there will be some visual differentiation so that the user knows which one is which, but they don't have to wait for the aggregation service to be fully integrated. So they can start the integration a little earlier. Before that, they can also use mock data to start laying out the UI, setting up the layout, defining the route, mocking any search filtering. They can start doing that. And the location filtering logic on the independent listing microservice, that can be done right away on Sprint 1. Another thing to consider is that this feature will be pretty useless until the user can select that independent listing and book the car. So it's possible that in this gap here, while there's some waiting period, while the engineers are working on adding APIs to that monolith, the engineers can do some planning and prototyping. And then at the last sprint there, I want to add testing and hardening and making sure everything is working nicely with each other. So what are the leadership lessons that we've learned here as part of this story? Refinement is essential for forecasting confidence. The amount of time you spend on each step of the process depends on the level of confidence that your external stakeholders are demanding of you. If there's flexibility in working together, you could essentially stop at the t-shirt sizing step of the process and say, let's move forward, and unknowns might arise. But if there's a high demand for high confidence, refinement is going to catch stuff like this and is going to give a high level of confidence. Uncovering unknowns early can avoid major future roadblocks. If we moved on assuming that the monolith had APIs, we would move forward with the process, and then a lot of engineers would be stuck and we'd have to plan work at that time for them. That would just not be the most efficient use of people's time. Proactive collaboration with external teams is invaluable. So building relationships with external teams and having that rapport and having those points of contact that you can reach out to and talk about their technologies. It's great to have that for efficient collaboration. Flexibility in project timelines is imperative. Like we saw here, the discovery phase showed that the assumptions we had on timelines were flat out wrong. So if you're going through this process and then presenting the full results at the end, you mitigate that risk of inflexibility because you're only communicating the delivery date at the very end once you have higher confidence. But if you're more collaborative with your external stakeholders and you start guessing with them early on, and they hear hints of dates and hints of complexity, and then start making promises upwards before you're finished with the process, that can cause a lot of conflict. Forecasting delivery dates isn't easy, but hopefully with the system, you can set timelines that are both realistic and achievable. It's also important to understand that releases and product-driven milestone dates are two different things. Value can be added incrementally with every release, and it's our job as engineering leaders to communicate the impact of each release. This is so that the individual contributors understand the value that they've added, as well as helping stakeholders understand the progress that's been made from sprint to sprint. Well, I hope that this content is helpful to you and that next time you're asked to forecast a delivery date, you can use these tools to come up with your own framework for estimating delivery dates. If you like this type of content, please subscribe. Otherwise, I will see you in the next one.